Alright, in this video we're going to look at two sequences, and we're going to find the 103rd term and then the sum of the first 22 terms of the sequence. So here I have a sequence that appears to be alternating between negative and positive, negative 1/3, 1/9, negative 1/27, and 1 over 81. It doesn't look like I'm adding or subtracting the same number over and over again, so it's probably not arithmetic. But it might be geometric, and what we should do is we should look at our common ratio, which would be to group two of the terms and take the second one and then divide it by the first one. And if we want to double check that, then we look at like the next two and take the second term and then divide it by that first one. So we're going to do that and see if we do have that common ratio. You might be able to just look at it and tell me what it is, but this is how we can find its common ratio. So we're going to group the first two terms, so 1/9 divided by negative 1/3. So keep, flip, and change, and that's going to give us a common ratio there of negative 1/3. Then we'll check the 1/9 and the negative 1 over 27, so the negative 1 over 27 is the second piece, so negative 1 over 27 divided by 1 over 9, so keep the first fraction, flip the second one and change the sign into multiplication. So we do get negative 1/3, so we can kind of see that if we keep multiplying by negative 1/3, that seems to be the pattern of this sequence. For a geometric, the formula is AN equals, your book just says A, I just call it A1 so I know which one that is. So A1 and then common ratio to the n minus 1. So we got all the pieces we need. A1 was negative 1/3. Common ratio happens to be the same thing. Now, is that always the case? No, it is not. Now what we can actually do is we can simplify this, and some of you had been asking about this during the workshop. This has an exponent of 1, so we can actually combine these because they are the same base. And this will give us AN is equal to negative 1/3 to the nth power. So we needed that before that we could find the 103rd term. We can certainly go through and multiply by negative 1/3 a whole bunch of times, but that doesn't sound like a whole lot of fun. So A103 is going to be negative 1/3. Sorry, that kind of looks like a 2. Let's make it look more like a 1 there. To the 103rd power. What I'm going to do is I'm going to just say that that number is negative, and I'm going to leave it to the 103rd power because it's going to be a giant denominator. 3 to the 103 is a huge number in term, and then this number is just going to be really small, divided into 1. So we're just going to leave it as it is. Okay. In terms for the sum, this is a geometric, so sum formula for geometric is the first term, A1. I'll put in the A1 in just a minute. It's A and then 1 minus R to the n over 1 minus R. That's what your book uses. I go ahead and just call it A1 so I know which one term it is. So this one's a little bit less work. I just need to know how far I have to go. So in this case I need to go to 22. I know what the first term is. I know what the common ratio is. So then it's just plug it in. And then just be careful when you put this into your calculators. The whole numerator and the whole denominator should have parentheses. If you don't do that, then you're going to get a different answer. So you need to be careful about that. Okay, so S22 is approximately negative 0.25. I double checked myself on Wolfram Alpha afterwards, and they said negative 0.249999, something like that. But that appears to be what the sum of the first 22 terms in this sequence is. Okay, so let's do another example. I think we did something similar to this in class. So 1 and then $1.25, $1.50, $1.75, and then $2. I don't think I write $2, but that's okay. I think we got an idea of the pattern. Okay. Either arithmetic or geometric is a lot of what we've been looking at. This one does not appear to be geometric. I don't see something that I'm multiplying by, but it does look like I'm adding a quarter each time. So that's my common difference. which is 25 cents. And then my formula, or I'm going to go ahead and tell you what A1 is. Your formula is AN equals 1, or A1, plus your common difference times n minus 1. So in this case, AN is equal to the first term, which is 1, plus common difference of 25 cents, and then times n minus 1. We'll go ahead and distribute that n through, and then we'll have $1 minus 25 cents, which is 75 cents, plus 25 cents times n. And that's our nth term formula to find the S103, not S103, excuse me, A103. We're going to go ahead and just plug 103 in and be done with it. That'll tell us what our 103rd term is, so we saved ourselves a lot of time of writing the whole list out. Okay, and that 103rd term is 2650. Okay. We're going to do the same thing with the sum. We're going to find the 22nd term. Formula for nth term, the sum of the first nth terms in the arithmetic sequence is has a little bit more we need. So it's going to be n over 2, and then a1 plus an. So we're going to have to find the an. So we need to find the AN formula. Well, luckily for us, we already did that. So we got that formula. This time we're going to plug in 22, and we already know what n is. N is going to be 22. We know what the first term is. So that's what we're going to go get. Is we're going to get A22, and that'll be 0.75 plus 0.25 times 22. Okay, so A22 is 625. So plugging that into our formula, S22 is 22 over 2. Then we have 1 plus $6.25. And then we'll go ahead and crunch those numbers in our calculator. And we get $79.75 as our sum for the first 22 terms. Okay. All of these, when they give you the pattern, they say, hey, what's the whatever term, and then what's the sum of the first however many terms. First figure out, is it arithmetic or geometric? So you'll need to know your nth term formula for arithmetic and your nth term formula for geometric. Then you'll need to know the sum formulas for arithmetic and geometric. Takes a little bit of practice. It's not real tough. Maybe the notation's a little scary, but you'll get the hang of it.